vast and fertile, provider of food, air, fresh and free, sustainer of life. Water, plentiful and pure, basis of all living things. Fire, source of light and heat, symbol of energy. Early Greek philosophers believed the physical world was made entirely of these four elements. And although much has been added to man's knowledge in the centuries since, the importance of productive soil, clean air and water, and abundant supplies of the energy fire represents remains unchanged. Our existence continues to depend on the careful management of each of these resources, balancing one set of needs against another. Perhaps nowhere can this relationship be seen more clearly than in our need for electricity. Even at night, when much of the nation's industry is at rest, the lights from America's cities and towns shine as beacons of vitality to satellites hundreds of miles away. The uninterrupted flow of electric power is essential to our way of life and vital to the future we're now building. But creating the electricity we must have involves choices. What energy source can we use to generate electric power, yet still preserve the quality of earth, air, and water? What energy source can we use, yet still have fuels for transportation, manufacturing, and other necessities? In answering these questions, we've found an increasingly important role for coal, America's abundant energy gift from the Earth's past. Energy we've learned to mine and use in balance with our present and future environmental needs. And a clean environment. Needs we must balance, one against the other. Today we realize that all forms of energy used to generate electricity have liabilities as well as benefits, that no energy resource is perfect. But leaders of a new generation of coal mining men and women are showing us that coal's impact on earth, air, and water can be controlled and managed. The result of a learning process that reaches back to the Industrial Revolution. In recent years, America has relied more and more on electricity to meet its energy needs. Coal generates more than half of our nation's electricity. Coal has become an increasingly important fuel by providing the energy necessary for a growing economy, while helping the nation meet its environmental goals. Coal use has grown by 81% since 1970. Yet the major air pollutants associated with coal burning have all steadily declined. Using coal in America today means complying with the world's strictest air quality laws and regulations. A primary objective of the Clean Air Act amendments of 1990 is to eliminate pollutants which have been associated with acid rain. Among other things, this law placed additional, more stringent emission limits on coal-fired plants. When fully implemented in the year 2000, These new requirements will cost utilities and their customers between $4 billion and $6 billion a year. Recent scientific attention has focused on the many complex atmospheric factors, both natural and man-made, which affect climate. Informed scientists disagree over whether a permanent warming trend is underway or will ever occur. They also debate whether the benefits of increased carbon dioxide, such as enhanced plant growth, outweigh possible negative impacts. However these and other questions are eventually resolved, it is clear that our nation and the world will continue to need coal to meet growing energy demand in the future. To meet this challenge, research is continually improving the ways of processing and using coal in a more environmentally acceptable manner. U.S. power generation alone will require the use of twice as much coal in the year 2030 as it does today. Much of this new electric power generation will likely employ clean coal technologies, innovative and unique processes for cleaning and using coal in a more efficient and environmentally sound manner. These processes hold great promise for further reducing emissions from coal burning, including carbon dioxide. Today, research facilities are bringing these technologies closer to commercial development. These technologies will help coal continue to meet both energy and environmental challenges in the years ahead. Maintaining the balance between our need for coal and our need for productive land is a complex task. While more than half of the coal produced is surface mined, coal mining uses only 0.1% of all the land in America. And coal miners work hard to return mined land to productive use. The process of reclamation actually begins long before the first ton of coal is mined, and continues long afterward. In America's heartland, those standards are being met with dedication and evolving know-how as farmland is restored to its original use.
I'm a coal miner, but also I am a farmer. I've lived on my farm all of my life, and it's been our goal to work cooperatively with members of the Soil and Water Conservation District Board, the Soil Conservation Service, and the local farm organizations in a way in which we can learn from them how to maximize the corn and soybean production here in southern Illinois. So we've been exploring ways in which we can reconstruct soil, and we have the ability now to change the structure, the texture, as well as the chemistry of the soil, so that our end product is equal and in many cases more productive than the original soil that we purchased from the farmer prior to mining. But even with that ability, we're finding that compaction is the limiting factor of production. So we're using bucket wheel excavators, cross pit as well as round the pits, in addition to different deep tillage devices. Right here where we are standing, just 5 short years ago, was a pit of coal about 100 feet deep. And now we've reclaimed the land back to the original topography. And I really believe if we have the same success as last year, this corn here will produce well in excess of 100 bushel.
Clean water also is essential to post-mining land use. And the delicate balance between our energy and water resources is carefully controlled through federal law. Today, The coal industry is working closely with authorities to protect and improve water quality wherever coal is mined. Drainage water from both underground and surface mining operations often contains dissolved metals and is acidic. Acidity is the natural result of water reacting with iron compounds in exposed coal or surrounding rock. Coal companies collect the drainage and neutralize it by adding hydrated lime at special treatment plants. The lime neutralizes the acidity and reacts with the dissolved iron to form solids that fall to the bottom of settling ponds. The clean water is then returned to nature.
There's a lot of creativity that goes with this work. Engineering, the common sense aspect of overcoming problems, moving the earth. I'm very proud of what I do. I believe there's a responsible attitude among miners. They are concerned about the environmental aspects. They're concerned about how we return the land. They're concerned about how the coal is utilized and what impact that has. It's a responsible group of people. We recognize that to be a viable part of the energy community, we are going to have to take that responsibility. And we're not going to do that because it's been legislated. We're going to do that because it's the right thing to do. We've come a long way.
Earth, air, water, fire. An ancient view of energy in balance with the environment, made meaningful centuries later by coal. Today, this dependable source of energy is helping us prepare for a future we can control. And one we've just begun